The three principles of experimental design are randomize, control, and replicate. So we're going to start with randomize. We've already talked about how important a random sample is because that'll give you a sample that's representative of your population. With experiments, we're going to add a second form of randomizing, and that's that we're going to randomly assign our participants to groups. And then each group is either going to be given a treatment or the placebo. So for example, we could give one group a 200 milligram ibuprofen, another group an 800 milligram ibuprofen, and then the third group, rather than give them nothing, we're going to give them a sugar pill. So a fake pill, and that's known as a placebo. We're going to talk about that in just a little bit. So the benefits of random assignment of subjects, it means that we're going to form groups that should be similar in all respects before the treatments are applied. So just like our random sample is representative of the population, when we break our sample into random groups, each of those subgroups should also be representative of the population. It ensures that influences operate equally on all groups. So if there are any outside forces that are kind of swaying the results, that should be equal across all groups. And really the only difference that we should see is what that treatment is that the group was assigned to. So the only difference should be whether you're getting a 200 milligram, an 800 milligram, or a sugar pill. This random assignment of subjects does not eliminate the bias, but it spreads the effects of bias out across the treatment groups. So we can do the best we can to kind of minimize bias or get rid of as much as we can, but we can't get rid of all of it. And so what randomizing does is it spreads that bias across all the groups so we can see past it to discover if those treatments are actually helping people. So in statistics, we say control what you can and randomize the rest. So do your best to deal with those sources of bias, but then know that that random assignment and those random groups are really what's going to help us to be able to draw our solid conclusions. Differences in the average response, if we've done this all correctly, we set up these random groups, those differences have to be from one of two things. So either the treatment is actually working and it's causing a change in the response variable, or it's just a fluke and we have random chance that is making the results appear something other than what they should. Okay, and so this is why the rest of these principles of the experimental design are important, because if we've done all of those things, then we should be able to say that the treatment is what's causing that change in the response variable. So we want to be very careful and thoughtful in setting these up so that we can actually get to that conclusion that the treatment caused the change. If experimental units were not assigned to treatments at random, so if I just said, okay, pick your favorite group that you want to be in, we would not be able to use the power of statistics to draw conclusions, and we would not be able to get cause and effect. So this random assignment of participants to groups is what gives us our cause and effect. One of the cool things is that randomization protects us from effects we didn't even know about. So if there are sources of bias there that we weren't able to discern for some reason or other, the cool thing is randomization will take care of that bias for us and spread it out across the groups. All right, so come back in the next video, we'll look at the second principle of experimental design, which is control.